everyone, and welcome back to Royan Study Corner. I am Royan, and the aim of this channel, or IGTV or Facebook videos, wherever you're watching this, is to make learning as fun, easy and accessible as possible. So in today's video, we're going to be talking about scientific notation or standard form, depending on what subject you're doing, what textbook you're using, or generally which one comes to your mind first, because they're the same thing but we just use different names for it. So this is part of the physical measurements and SI units section, which is the one that I said isn't explicitly stated in the syllabus, but we still have to know how to do it to work out everything else. So what is our learning objective? Now, our objective of this video is to express numbers in scientific notation. So hopefully at the end of this video you'll know how to do that. So before I say so quite a lot, before we can actually convert things or express things in scientific notation, we have to actually know what scientific notation is. Scientific notation is a way of expressing numbers that are too large or too small to conveniently be written in decimal form. Decimal form is just basically the way that we always write numbers. So 50, 25.3, 0.002578 9 is a decimal, or all of them rather, are written in decimal form. So when a number is written in scientific notation, it is written as a by 10 to the power of n, where a is the coefficient, meaning just a number, 10 is our base, and n is our exponent or index or power. You can use any word, they all mean the same thing. Now a must be a number between 1 and 10. So it can be 1, it can be 9.9999999, but it can't cross that and go over to 10. So between 1 and 10. So why do we use scientific notation? As we just said, it's when something is too large or too small to be expressed easily the way that we usually write it. So if we look here, we see another example that I love to use, the diameter of an average atom. In decimal form in meters is 0.00000000001 meters. Now, it's easy to forget one of those zeros to accidentally add in another zero, so there are easier ways to write that. And we know one easier way that we learned of last video is to put a prefix to write it in that way. But this is another way that we can shorten it, where it would be expressed as 1 by 10 to the power of negative 10 meters. So in this case, 1 is our coefficient, which is between 1 and 10. We have multiplied by our base 10 to the power of negative 10 meters. So converting to scientific notation. This is a step-by-step procedure. I don't know why that is the way that came to my mind, but a step-by-step procedure of how exactly to convert from decimal form to scientific notation or standard form. So let's see. First thing is, place the point in the coefficient to make the number between 1 and 10. Number 2, or step 2. Place any random mark, I'm just using an asterisk, at the original decimal point. Number 3, to get the power, we move the new decimal point to the original point, which is where we place the little whatever random mark you want to use, and the number of Now the number of jumps made is the power or exponent or index. If the point moves to the right to get back to its original point, then the power would be positive. If the point moves to the left to get back to the original point, then the power would be negative. Now I know this seems a little bit abstract, just reading something and how to do it, so let's try some examples. So, our first example asks us to convert 564,000 to scientific notation. I don't know why I'm writing all of this out when it's clearly shown in the PowerPoint, but yes. So we have 564,000. So when you have a number like this, it's understood that the decimal point is at the end of the number. The first step is telling us to put the decimal point now in the place that will make this number between 1 and 10. So let's just write it down here, 564,000. The place that you'd have to put the decimal point for it to be between 1 and 10 in this case is between 5 and 6. So that we'd have 5.64. Now step 2 tells us to put on a mark at the original decimal point. So the original decimal point will be at the end here. Now, how do we get the power? The power would be found by the number of jumps that we make from the new point to the original one. So we're going 1, 2, 3, 4, 5. So 5 jumps. And what direction did we move to? We moved to the right. So that means that the power must be positive. So let's write this out now. Our answer will be 5.64 multiplied by 10 to the power of 5. And that's it. Let's try another example. Our next example here is convert 0.000759 to scientific notation. Now we're going to come back to our steps here to see what we have to do. First step, put the new decimal point, which has to be in such a place that it makes the number between 1 and 10. So if we put the decimal point between 7 and 5, then we'll have 7.59. So that's where we're putting it. And then we put a mark where the original point was. In order to get the power, we have to count the jumps from the new point to the original point. So we're moving 1, 2, 3, 4. So we have 4 jumps. And this time the 4 jumps move to the left. So we have to the left, which means that our power will be negative. So our answer now will be written as 7.59 multiplied by 10 to the negative 4. And voila, that's our answer. So it's literally the same procedure that we'll use over and over anytime we want to express something in scientific notation or standard form. Now, just as we just express a number in decimal form, we were able to express it in scientific notation or standard form. What about the reverse? Sometimes they'll give us a number in scientific notation and expect us to write it out the way we usually would. So let's look at how to do that. First thing we do is we look at the power of 10 to determine how to move the point. Now, what does that mean? It means that the number tells us how many places to move the point. So the numbers in the power tells us how many places to move the point. If that power is positive, it means that we have to move the point to the right and if that power is negative, then we have to move the point to the left. So our next step is to move the point in the direction determined and the number of places determined, even though I have placed here, but you know what I mean. Hopefully I remember to fix that after. And that's it. That's how we convert from scientific notation to decimal form. So let's try some examples. Convert 6.5 by 10 to the 4 to decimal form. So what's the first thing we do? We look at this power here, and we're seeing that the power is 4, so that means we have to make 4 jumps. And is it positive or negative? If there's no sign in front, it means it's positive. So if it's positive, it has to move to the right. So 4 jumps to the right. Now let's look at this. So we'll have let me not use that color. We'll have 6.5, and we're making 4 jumps to the right. So we're going 1, 2, 3, 4, and our new point will be here, and let's add in our zeros in all of those jumps. So our answer here is 65,000. So 65,000, if written in standard form, will be 6.5 by 10 to the 4. Let's try another example. So our next example here says convert 8.9 by 10 to the negative 3 to decimal form. So what's the first thing we do? The first thing we do is we look at this power. So hey guys, sorry about it, but I'll just be doing a voiceover from this point on. So if we look at the power there, we see negative 3. So since there's a number 3, we'll have 3 jumps. And because it's a negative number, it means we'll be making 3 jumps to the left. So we write our 8.9, and let's move our point those 3 jumps to the left. Now we have 1 jump, 2 jumps, 3 jumps, and we put our new decimal point. Now our next step would be to draw in our zeros in those empty jumps. So our answer now is 0.0089, and that is our answer for this question. So I hope that was helpful, and I hope you all enjoyed the video. Remember to be safe and be kind to yourselves. Look out for the next video that will be coming out next week, and I'll see you guys then. Bye.